Today we're going to be learning how to fix icicle lights. Here's a typical light strand. It actually consists of 3 different strands of light that are connected in parallel. This is the start of one of the segments for this string. So there's 120 volts coming in, and it goes out. In this case it's the end, so it's going to go out to the plug here where you can find 120 volts. If you don't find 120 volts at the end on a lit light socket, then you know you've got a problem with the wires. Okay, so 120 volts comes in, provides power for this section of the lights, and if any one of these bulbs go out, then what's supposed to happen is that when the filament burns out, there's a little shunt at the base here, and that shunt has a non-conductive insulator over the shunt wiring. But when it burns out, that insulative wire is supposed to somehow burn out, and then that shunt is supposed to short circuit this particular light and then allow the current to flow through the rest of this series. And what typically happens on indoor lights, at least, is that shunt burns out. On outdoor lights, that could be the problem, or what I've typically found is that you have a problem with one of the wires maybe being corroded by rain. So anyways, what we got to do first is make sure that all of these bulbs are here and they're not broken and there's no loose wires. That's going to be the first easy thing to check. Oh, right here, here's a broken bulb, so let's try replacing that and see if that helps. Okay, so the question is, how do you replace these bulbs? You're going to end up having to pull a lot of bulbs typically, and I've tried a number of different ways, and the easiest thing, most reliable thing, is to take a very small pair of scissors. In this case it's off of a multi-tool, and I'm going to try to get these scissors in that very tiny wedge there between the two, and then I'm going to use my thumb to pry up, and it just slides right off. So you take that one out, you've got your replacement bulbs, and there are 2 different, I guess at least 2 different voltages, 2.5, 3.5. I'm using 3.5. I probably should be using 2.5, but it doesn't seem to really make a difference. So okay, so I've replaced this bulb, but no luck, still not working. So another thing you can try is you can use a non-contact AC tester like this. So this senses AC voltage without having to actually touch the voltage. When it gets close, it goes on. Now you want to calibrate this so that just when it comes up to a light, it's going to go off and not any sooner. Start here. That doesn't seem to be helping, and that's pretty typical for the non-contact AC testers. It's oftentimes not very helpful. Okay, so the next step is to see if we can actually fix one of these shunts. Now, there's a device out there called the Lightkeeper Pro. It's kind of a gun thing, and unfortunately I could not find one of those in the stores. But what it does is it sends a piezoelectric shock down one of these sockets. And so what I've done is I've got a barbecue igniter that I just took out of a barbecue, and I've hooked up wires through a bulb socket here, and it's probably very hard to see. Ooh, I just got shocked. It's very hard to see, but there is a little spark going between these 2 wires. I'm going to take my socket and plug it into the socket. Now I'm going to shock it a couple of times. Now, theoretically, if it was going to fix something, it should have already fixed it, but sometimes I've seen that after you plug a bulb back in, okay, so that didn't seem to work. That's not to say that the problem isn't the shunt. It could still be the shunt, but it may not have been cleared. So we have to try another method. Okay, now comes the final solution. You're not going to like this method, but it does work. So what you need to have is a voltmeter, AC voltmeter. It'll read 120 volts. You plug into the female end, doesn't matter which blade, one or the other, and then you take the other probe and you stick it in the socket while it's plugged in, and you might be able to see it says 22 volts on one side. I switch to the other side, it says 120. Okay, that's what we want, 120 volts. So the power at this point is fine. Then what we need to do is move on down the line. Go to the next one. You can jump around too if you can be like a programmer and go on a binary search and skip halfway down the line. It may also be that you need to go to the other end to find where you have 120 volts. Okay, you can't probably see that, but it says 120 volts there as well. So I'm going to keep on going down the line until I find one that doesn't say 120 volts. The line was fine up to that point. Pop that bulb out. Let's take a look what we got here. So 12 volts on one side, 22 volts on the other side. Okay, so what that means, let's put this one back. The problem is not here. The problem is actually back here. So I had 120 volts here. That voltage is supposed to go down this full string, come back up, and then move on to this guy. So the problem is in this string. So now what we need to do is check each of these bulbs and see whether we're getting 120 on each of these. So I'm going to take off this second bulb going down the icicle now. Let's test the voltage here. 12 volts on one side, 120 on the other. So this bulb is fine. Now I'm going to go down the rest of the string here, and I'll tell you when I find the problem. Okay, so here's the very last bulb in the string. Everything else is showing 120 volts. I test this one, I get 12 volts off of one side, 13 volts off the other side. So this socket doesn't have 120 volts. It's not the problem. The problem was the previous one. Let's take another look at this. First I'm going to check the wires, make sure the wires look okay. Let's go back and pull this again. Let's double check this voltage. 14 volts on that side, 120 on that side. So I think what we need to do is just put a new bulb into this particular outlet, and it should be working. Okay, so I've put a new bulb in here. Press it in, and nothing. That's a disappointment. In fixing many sets, that's the first time that has happened. Let's double check and see what happens to this next outlet here. So remember, this one was registering like 12 or 13 volts. Now it's got 120. So we did fix a problem there, but unfortunately that's not the only problem. That's very rare, so I'm going to have to keep on looking. And the question is, what happened to that other bulb? Well, here's the bulb that I took out of there, and you might be able to see there's only one lead on this bulb. Now here's a tricky case. So I found 120 volts going down the line from the lit part all the way down to the second to the last bulb. This last bulb here only had 80 volts in it. So I assumed that meant the problem was back here. I tested each one of these going down the string, and each one had 120 volts. And it wasn't the last bulb here, which typically would have been the problem. So I thought, maybe I need to look down this string. And I found this bulb here. Let's try putting in a new one. Ta-da! Okay, so we got our string to light. So it's not always the previous one that's the problem. Sometimes it could be the actual icicle where you find the problem voltage. Pretty much this is guaranteed to work because it's all just electrical connections, and you can make it work.